Now, just the Department of Mechanical Engineering at the University of North Texas, where he's been a lecturer since. On? Yes, that's all. Is it? Okay. Where he has been a lecturer since 2021. Before joining North Texas, he worked as a mechanical engineer for more than 7 years in the oil field maintenance and energy business. Hassan received his PhD in mechanical and energy engineering from UNT, and he received his master's degree in energy management and bachelor's degree in mechanical engineering from the University of Jordan. So he's a very educated person here. Presentation is about the U.S. Department of Energy Solar Decathlon, which is a collegiate competition that includes thousands of students worldwide that enter into this clean energy workforce since its inception in 2002. Today, there are 10 contests that are foundation for the Solar Decathlon Challenge. The Solar Decathlon Challenge students to design and build high-performance, low-carbon buildings that mitigate climate change and improve our quality of life through greater affordability, resilience, and energy efficiency. The winners of those teams that best blend architecture, engineering excellence, and innovation. And I understand the UNT team came in second in that competition, which is very, very good. And so Hassan will be here to tell us all about how they managed to do so well and his expertise. So here you go, Hans.
Thank you so much. Hope the voice is on. It's really nice to be here. Thank you so much for this invitation. And I'm excited to first get introduced to thank you. Perfect. Okay. To this amazing group, I think we needed to actually work with you guys, and we needed your expertise, and we needed your wisdom when it comes to renewable energy. Being a UNT and being with the mechanical and energy engineering department, it's been a struggle for us to find experts in this field. It's been a struggle for us to actually get students to be having this kind of exposure. So thank you for doing what you're doing. And coming from a few degrees in energy and renewables and doing my master's and my PhD also in renewables has been a great journey to introduce people to actually the importance of renewables in the first place. Thank you for the introduction. I worked, as mentioned, in the conventional side of the business in getting wells in different parts of the world. We just had a chat, worked between India, Malaysia, Thailand, Germany, Turkey, UAE for more than 7 years. Actually, 7 years was a shorter term. It was about like 8-9 years. And I think seeing all this craziness and like how the business would go up and down, so crazy that like people's lives actually depended on it. You have no idea how many peers I had to witness leave the company and then asked to be rejoined because the oil prices are better now. So, and from another perspective, living in Jordan, living in the Middle East, where people actually, Jordan was one of the least fortunate countries in the Middle East where we don't have oil. Guess what? So we have that reputation of being in the Middle East, but we don't have any oil. That's maybe that's why we're safe. We don't have any problems. No, but what happened was we got to understand the importance of having security when it comes to, or sustainability when it comes to power. And that's where the Jordanian government, we have the highest or the most densest population of engineers worldwide. People wanted to go and do engineering, wanted to go and do renewables. And that's where I got to actually be introduced to mechanical engineering in the first place. Fast forward, coming to this country where I decided to leave the oil field and I decided to pursue my dream of having a PhD in the thing that I love the most. And I did my PhD in concentrated solar. We were designing thin lenses to actually concentrate power and use it for other purposes. Eventually, I came to an understanding that first, this place, actually Texas, and I always go out to different countries and different states and say like my experience being here, coming here by chance, by the way, it wasn't intentional because I have like family in other states. It was the most amazing experience how like doors were open so widely and like I was led into and all those opportunities were just like handed over to me and like, if you can do it, go run for it. And that's where this thing came from. So passion about teaching has always been there. Passion about passing this knowledge and passing this, I would say, message for the next generation to love energy, to love renewables, to love sustainability was always important to me. But I was so caught up with doing senior design projects, because that's what I did after I joined UNT. And I'm doing now, I'm the senior design coordinator for the department. I get random emails, as you might all do, from different parts of the world. And I got this email in my junk mail, I'm not saying, it's like in the spam, from the solar decathlon team. Personally, I have never heard of it before that email came in. And I had a colleague, his office was next to mine, and he told me like, hey, did you get, this sounds interesting. His came in the actual mail, mine came in the spam. So he came to me and he said, like, are you guys interested in doing this for senior design? He did not even know the intensity of this competition. We didn't know. And up until this is the first time they did the midterm presentation or the semifinals. I was not aware of how competitive and how many schools were actually competing in this. And I was just randomly, I went to my class and I said, well, we have this competition with the DOE. You guys are interested? Well, somebody said the DOE, yeah, I'm interested. The guy, his name was Andrew, is the guy right here. I think there's a pointer, if I'm not mistaken. Yeah. He's a team lead. He said, yeah, sure. We already have a project that we're not interested in. So let me do something that's more interested. And that's what we did. Neither me or them, we knew what we're signing up for. We went to the website and then they started reading the requirements, and we were like, oh, this is more an architectural kind of work. We need architects, we need senior, like interior designers to work with us, because we have no idea how we get to that point. And that's where like you go into like this back and forth, like, do we do it? Do we just quit? Do we do it? Do we just quit? I personally am not a quitter. And I take success very, very dear, very personal. So we said, we're going to do it. So we took one presentation of the whole presentation that was like the winning teams from previous years. We blocked everything else. We decided, hey, we're going to do better than this presentation. That's it. That's what we did. So then we got to work with somebody from Gensler. It's an architecture company. We got introduced to them through a student who used to work at Gensler. She was doing her third degree at UNT, third, and I'm not. She had the first degree, I think, in the 90s, early 90s, and like she's doing a third in construction management. And then we asked them, like, what do we do about this? Like, what do we compete with? They had 6 divisions at the Solar Decathlon this year. And the first thing that came to us was, how do we create need? What do we need to build? How do we stand out as a team who doesn't have architects with them? So the advantage for our team was we know a lot about the technical stuff with renewables. We know how to make energy out of everything almost in this environment, where the architects can only design buildings with visuals of these systems. No offense to any architects over here. So what happened was we decided we wanted to create this need, that we want this building to be very efficient for that specific purpose. So I partnered with Professor Bill Morgan. He's from the College of Visual Arts and Design. He was also an architect. He's also a practicing architect. We got 2 students. We get Anne-Marie and Adeline from that college, and the rest of the team, they're all mechanical engineering students. I have here, you see Dr. Zhao Weihuan Zhao. By the way, Dr. Zhao was actually my PhD advisor when I was a student. So now I was the team lead in the team that she was participating in. And I'm humbled by that. I was actually her first PhD student at the time. So this is how, going back to the opportunities and like opening doors for you. So we decided we wanted to actually build something for the students. So I'm not sure if anybody has been to Den. For some people, it's amazing and it's great. For some people, it's like in the middle of nowhere. So Den has its own main campus that's in the center of Den, and we have for the UNT, and we have the College of Engineering, which was a building donated by Texas Instruments. It's to the north of the city. It's about 15, 20 minutes north. And the College of Engineering is a huge lot. It's a huge lot. It has very small building compared to the lot size. Probably no more than 20% of the lot size, 25. But at the same time, we have the majority of graduate students going to the engineering school. And I was one of them. And that's where the need came from. So I was like, hey, I myself, as a student, struggled to go to school every day. I had to take a bus. And even if I had a car, I was paying gas. And I had a family. And I was not sure if I'm going to make it to class in the morning. And I actually used to work, live, breathe, research, do everything on campus. So it made no sense for me to actually live off campus in the first place. But we have no student dorms on campus, and we didn't have at the time apartments nearby. And even now we do, but a one bedroom for a student now there, it's about $1,600. And you're talking about Denton. For a student, a TA, teaching assistant student, who's coming from a different country, let's say most of our students are coming from India, they're getting paid $1,200, $1,300 if they have a job on campus. So how do you afford to even live off campus and pay all of those extra internet? You're paying transportation, you're paying water, you're paying electricity, all of those things. So the need is there. We wanted to create a space for graduate students to live on campus in this very unique and fun atmosphere. And that's where this building came from. The project, we're trying to reduce the power consumption. We're trying to build a student housing on the lot of Discovery Park. And we wanted to have a cutting edge sustainable living. This is our own building. We're gonna live in it. You know, when you're building your own house, you wanna make it the best. You wanna put everything that's so amazing in it so people, you can brag about it in front of other people, in front of your guests. I do that, by the way. I love that. My dad told me how to brag about your house. All right, so we did a little bit of a market research. First, we researched what is Den. We wanted to introduce Den to people. We did a little bit about the water, the rainfall, the sunshine, and how much sun are we getting. And we did a little bit about the wind. We even we did do a wind analysis. We actually, I'm not sure if it's showing. It should be showing. Maybe if you can reduce. Yeah. So we did the wind row. Yes, we did the wind rows, and that helped us a lot because what we did, we realized that very few teams ever in the solar decathlon utilized wind. And I was just mentioning in Texas, if we were a country, we would rank 4th in the world in wind production, more than China. That's how big Texas is in wind. We have the best wind in the world. So we studied the wind, and this is the lot that I was talking about. This is the existing building for the College of Engineering. So we have more wind coming from this side. So what we did when we designed the building, I'll answer you, we angled one of the wings of the building to face the wind to harvest as much as energy as we can. Yes, sir. We utilize existing data, yes. There's a few websites out there you can actually go and you input your latitude, longitude, and then you do some analysis. They give you those nice charts. We tweaked a little bit of those charts, but we use existing data, yes. Sorry. Most of the data that we have here that we present is actually as per the NREL requirements for the competition. So we took, we got really like overwhelmed with the amount of documentation that we had to read to go into the competition. But what part of it was actually the reduction wasn't 40%, was less than that. But we wanted to go like, we wanted to be beyond the requirements. Like I will show you other numbers that we wanted to actually, okay, this number is saying this. No, we want it to be much better than that. Yes, yes. Yeah. We definitely, actually, that was the reason we went into the competition in the first place. We built one. And that's the story of that building. We have an existing net zero energy building now. The story of that building is very interesting. We had a department chair, founding chair of the mechanical engineering department at UNT. His only condition of joining UNT was to actually have funding to build that building. So he forced UNT to build that building. And it was a replicate because we went on and we built other buildings afterwards, similar to it. We did a lot of research. We made a lot of publications out of that building. I worked in it. We still work on it. So it helped us a lot understand what a net zero energy building is. But it is nothing compared to this scale. Yeah, it's very small. So we even did market analysis on the location. So we kind of scoured all the apartments that we had around us. How do the students go actually to get from main campus, main city where most of the apartments are, to go into the main, to the Discovery Park, which is right here. This is the bus route from UNT. We studied how much is a one bedroom. It's as high as as I said, $1,500. So we also studied the population. Who's going to live in our space? As I mentioned, most of them were, if I'm not sure if this data is public, UNT had a goal of reaching, I think, about 9,500 students, graduate students by 2025. We reached that number last year. And it's growing like in an increasing, crazy rapid way, especially in computer science and mechanical engineering. So there's a need. And most of the students, as you can see, the green here is mostly from India, 1628 students. And those are international students. They're leaving their homes, they're leaving their land. And I lived in India for 3 years, and I know what it means to be going from that to this. So we decided to partner with few experts to ask them, what is it even feasible to do this building? And I'll show you what this building is. We did this is based on existing dorms at UNT. We went to a company called HBJ, and the vice president, his name is Fadi, is a good friend of mine. And I asked him, like, hey, Fadi, is it even feasible to do this? We wanted a building that's complete timber. We wanted a building that would be very energy efficient, less units, more space for people to do stuff. So we estimated that we needed the building, after our calculations. We said that the total building cost would not exceed $43 million, $44 million, which is a very good estimate. We based it on the total building area of 125,000 square feet, total built area. And we wanted to get that money back within 30 years, 30-ish years, which is the lifetime of a mortgage nowadays, right? So within 30 years, your mortgage time, you're going to pay off your building and then live free afterwards and actually make money out of it. And then we decided to study the stages of this building as we go, based on the experience that we had before, and we wanted to finish it by the first quarter of 2025. So the design goals were very firm. These are the 9 goals that the DOE, the Solar Decathlon guys, would actually give you to follow, going from architecture all the way to energy performance. And we wanted to have a concept based on the technology rather than the building. We came up with an amazing building, don't get me wrong, but we wanted to have the most sophisticated technology in the building in terms of HVAC reduction, in terms of sustainability, and in terms of renewables. And I'll show you what that meant in a second. So we studied, if you see the building is actually angled have 3 wings. And one of the wings is angled, as I mentioned, to actually harvest as much wind energy as we can. So we had studied the urban edge, the rotate. Those are actual architecture terms that I'm not an expert in. But we had partnered with, as I said, Gensler. We had partnered with Bill from the College of Visual Arts and Design to help us with figuring out this perspective of the design. We thought about landscaping. We even included a turbine wall, a wind wall. And that was one thing that actually won us the competition. And we have a better idea for next year. And I promise, we have way better ideas for next year. Now we know what we're going to do. Now we know what they want. So we even removed some of the units. So we would like, you see those apartment buildings, they have like complete condensed units next to each other. We removed some of them to have better circulation of air throughout and to have areas for people to actually sit around and enjoy their time. This is the top side of the top view of the building. It's already available online if you wanted to look at the details of this. And it shows you, this is at the edge of the lot of the Discovery Park. This is the whole lot of Discovery Park. The dark colored building is the existing building right now. And we wanted to build it at the edge. What is here is actually just a parking lot. So students would literally walk to go to school. So there's no commute. We have few facts about the building. It has about 38 one-bedroom and 57 two-bedroom units. And we have, as I said, 7.5 acres total area. It's spacious. It's like we're in Texas. We needed to go bigger than other people. We had about 150 parking spots, and we needed a paved trail for people to actually walk around and enjoy this space as well. So these are the levels. This is the first level that has most of the common areas that we'll talk about. We have the second level up until the 5th level have different units. You can see we have on the 3rd level, there's a bridge that connects those 2 wings together. By the way, I don't know if you know a lot about UNT. UNT is the Mean Green Eagles, right? So this came from the wings of an eagle. This design. So that was another. On the top, we have a planetary here where people can actually, it's like a viewing deck. You can go and enjoy the plants and even eat if you want it and still enjoy the view. So this is the unit from the side, from the section view. You can see how the removed units actually give you a better perspective, better circulation. We have I'm not sure if you can see it, but we have this is with and without the wind wall. The wind wall gives you shade and energy and aesthetics, because you can color these with whatever color you want, and you can even have them light up at night. Yes, sir. So I'll get to that wind wall in a second, but the wind wall actually basically just vertical axis wind turbines, VOWTs. So the wind turbines rotate, and at the bottom of each rod that has different like turbines, there is a generator that feeds into an inverter that gives you power. That's the basic idea. And this is just a rendering. We have the actual system designed by the students, by the engineers, as we go on. Some views, we have the patio view, the pool. We wanted to have a pool for people to enjoy themselves. It's not existing sometimes in student dorms. We don't have pools, actually. We have also included a lot of thought about the interior design. That's where the students of the interior design came to play. They thought about indoor plantation. They thought about an indoor cinema, theater. All of that is like a community area, a laundry space. All of those actually very friendly looking, very fashionable. We thought about, as I said, wall plantations where people would actually see flower grown on the walls, vertical walls exactly. You can see them actually here. So this is a wall plantation. This is the name of our space. It's the nest. Yes. It's all only that we designed it for graduate students at the College of Engineering, which it's a huge population. Oh,
Was the students that are attending it, as far as the graduate students, was it for the entire college, or is it just for the Department of Engineering?
it was for the Department of Engineering, but definitely it would make more sense if somebody has more classes at the College of Engineering building. People from the science College of Science, I guess, or something, they would be able to live on campus. But it's mainly for engineering graduate students. That's the main idea. For TAs and RAs, people who actually live and work at the campus. Oh, sorry.
So have other departments, since you've done this and received the award, have they reached out to you for interest in doing something similar?
So now I'm already involved in construction, as I mentioned before, in a new design studio for UNT. So this project has been conveyed to the facilities of UNT to see the feasibility of it. Because if the UNT would make this project, they would need to partner with somebody to actually have the funds and build it. That's how they do with old dorms. After this. All right. So we had a play area. We had the pit where you can actually present a movie, have a movie night. Very spacious community, common areas. We had an energy cafe where you could actually go and drink coffee and have food that we actually plant. And I'll show you what that means. We actually harvest vegetation from the same spot. They thought about the material boards and the material that we need into the interior design that needs to be very sustainable. It needs to be approved by most of the certifying like LEED and Energy Star and all those efficient building certifications. More of the cafe and the living walls you can see in the interior designs. So these are the two units that we have. We have the 1-bedroom and a 2-bedroom. We had a very exciting time with the judges telling us like, hey, the 2-bedroom is very tiny. It has only 1 bathroom. So the debate was like, you only need 1 bathroom with your partner. Why you need to separate bathrooms? And that was a very heated debate in a very fun way. So we have tinier units, only what the student would need. We wanted to encourage students to actually be outdoorsy more than they actually stay in the unit. More of the features. So we started now looking at the interior. We started looking at the placement of the actual lighting. We started looking at the placement, like how the flow of light and how the flow of wind would go through the unit. As you can see, also the placement of the HVAC units and how we have a drop-down wall here above the first space, the first entry. And you can see how those walkways would actually give you more shade, so that would lower the HVAC load of the space. So, and then we did, of course, and this is what we do best, being mechanical engineers and being energy engineers, we do the best energy assessments. And that's what we bragged about in the competition. So we did very vigorous, it's not showing here, I wish I can show you more of the numbers. We did very vigorous construction performance and energy performance for the building that we already have. We utilized the DOE's software to actually do this energy efficiency assessment. We also went through a lot of iterations of actually how do we make this more energy friendly, I would say. Yeah, exactly. And we thought about the renewables. So this is where the exciting part starts. So we have 6 different renewable energy considerations in the building. We wanted to do rainwater harvesting. So we have 0 consumption of water from the city. We wanted to do wind energy harvesting. We wanted to do on-site food production. we already have geothermal wells that we want to utilize. We already have about 12 of them. We wanted to utilize solar arrays, obviously, and we wanted to have a methane plant where we use the food, the remaining food of the units on them, and actually whatever we have out of the food production facility, we wanted to reduce methane with it, so residents would be able to use it.
So I have a,
As far as we know,
I have a question.
Yeah.
The rainwater collection, you said that provided all the water,
yes,
even drinking water and showering water?
Yes.
And so you have some process to
actually the current zero energy building, the small that what we talked about, is harvesting water, and I've drank rainwater so many times when I was there. So we have a very elaborate filtration system
Okay.
that we've been utilizing. Yeah. We designed 2 different filtration units. One that goes into like the use of people, like for drinking and showering and all of that, and one goes into the vegetation and to actually help with farming purposes.
And so all year long, that provides enough water even during
Yes,
our.
the gray water plus the rainwater actually provides what we needed. Actually, you remember, it's a net zero energy. So you give and take, you give and take. Water we might use for some months, but we discussed this afterwards. We said if we just add another tank, we can completely get rid of the city water. Yeah, sorry.
Thank you. What percent of the energy is produced, of the overall energy is produced by the wind energy, and how much is it from solar?
Great question. I'll get to that. Great question. I'm sorry, this is a very long. Somebody needs to give me a cue on time. I don't want to be. Okay. I'll be here. I'm happy. I'm happy. I'm happy to be here, by the way. Thank you so much for your questions anyway. I love that. That's exactly what you were asking. So this shows you, sorry? This is a very quick summary of the energy production of the building. So we decided to do this project in 2 stages. Stage 1, that would have a certain amount of all sorts of renewables. Stage 2 is something that we didn't actually include in the study. We proposed it. If you wanted to elaborate, we have the space for it. We have the resources. You just need to build it. We did not include it in the budget. That's what I'm trying to say. Stage 1 was based on a total demand of the building of about 720 megawatt hours per year. And that's what we based our energy modeling on. So we had 4 sources to meet this specific demand. We had PV on site, and we had on site, which means on the parking lot of that specific building. And we have an adjacent parking lot that is already existing right now called Lot 93, that we can have 50% of it covered with PV as well. We have wind and we have biofuel. Those are the 4 sources of the first stage of renewables actually utilized. We estimated after the calculations, you can see even, I'm not sure if you can get to it, like the PV on site would save us about 500 tons of CO2 a year. That's where we calculated the savings of CO2 yearly, and that's where we met the 40% reduction. Actually, it was more than 40%. We had about, here was 1,500 unit modules, and here we had about 1,100 modules on those spaces. Wind wall was about 32 wind walls. By the way, those wind walls are designed, manufactured internally. So they're UNT innovation and they're UNT production. So we're not outsourcing. It doesn't exist in the, like, we're not buying, we're not buying it from somebody. That's what I'm trying to say. It does exist, but we're not buying it from somebody. That's a different story. That's a different story. Yeah. Because the design pattern is already there. You just need to convince the right people to do it commercially. And normally to convince a state institution to go to commercial, it's kind of hard. If anybody has, but maybe I'll be going to the Shark Tank and presenting my idea afterwards. Biofuel, we had a one biogas plant that produces about 18 megawatt hours per year. So we have 18 megawatt hours. We have 1.1 gigawatt hours per year. We had 1.72 megawatt hours per year. Oh, so 1,720 megawatt hours per year. We had about 20 megawatt hours per year from wind. I think this is megawatt hours. This might be the wrong file. Okay, so we had 2.2 gigawatt hour excess energy production per year. And we're actually making about 80 grants of that excess energy after the whole calculations. Yes, sorry.
Can you talk a little bit about that interconnect and selling back to the grid? You know,
Yes.
as far as what the market looks like up there in Denton.
Definitely. I'll show that in the next slides, specifically after this one. Just an overview how much energy production we have per season, and obviously we have more production in the summer season compared to the other season because of the abundance of solar energy. Oops. Here it goes more elaborate on the water collection system. How do we collect the water from the roof and from the parking lot? We have permeable pavement on the parking lot. We collect this water and then we send it mainly for the purpose of drinking water. We collect it from the roof. And then on each level, we have a tank. That tank fills out and then collects into the next tank and the next tank. And we have specific, very small filtration units at each level. So we won't have to overwhelm. I don't want to like just filtrate all the water that I have. I want to filtrate as on demand. That's what I'm trying to say. So that's where we have different tanks at different levels. And we have a major water tank that goes after those tiny underground storage tanks for water collection. You wanted to ask? So
on an earlier slide, you showed walking areas.
Yeah.
And you called them paved. And the thing is it actually a permeable walk surface so that you're allowing, natural flow of water through the landscape?
The walkways are not permeable. Only the parking spots are permeable.
So why did you choose not to use permeable for your walkways?
That should have been chosen, but the main purpose of that, I think the walkways were mostly shaded. We wanted to have shade on them, so it wasn't going to collect a lot of rainwater underneath. But the main way actually was not the permeable pavement, was the actual solar panels themselves. So we were collecting rain through the solar panels. And actually, that's a very common way of collecting rainwater for a lot of the different facilities out there utilizing net zero culture. So this rainwater would actually collect on the specific solar panel. Then we have a gutter kind of system that I think the slope was about 1.5 degrees to the one side. And then we collect the water on this side and get it to the tank. That was the main idea. That was the main way of collecting rainwater, if I may say.
So question here, does your tank provide sufficient head pressure for the water distribution, or do you have to do more?
Exactly. So another reason that we did this separate tanks at different levels to reduce the amount of pressure, to reduce the amount of pumping power that we need for this water. Because if you collect it at the same level you're using it, you don't need much pumping in the first place. But if you get it to this tank, you're pumping it up, and then you probably need to do a little bit of pumping to get it back to this specific height. So collecting at each separate level from a head perspective, from a pumping perspective, was saving a lot of energy in the first place. Does that answer your question?
Yeah. I have another question.
Yes.
Sorry, to nickel
Sure.
and dime you like this. So on your solar panels, did you optimize the slope for our latitude to maximize your power production and maximize your water collection?
So the slope was as per the norm of the industry. It's the slope of the solar panels is supposed to be the latitude of that specific spot. I come personally from a very elaborate solar tracking. We did a lot of research on solar tracking, dual axis. I even tracked solar energy with lenses. So that was something that's even more ridiculous because we wanted to have the spot of the main spot of the lens at a specific point. We cannot move it anywhere. So in this situation, we were just not doing the tracking system. We're just leaving it at the industry standard because that adding more mechanisms to it and making it more a tracking system, it would add cost to it, to us. And I'm not sure if that's a good question. If we would change the slope of those solar panels, would it change the water collection? That's a very interesting question. And I would definitely would want to learn about that more. But we didn't do this. We didn't do this specific study. We left it at the industry standard. Oh, it's 31. Yeah, we left it at 31. It's like 1 degree below the latitude. It's where 30. Yeah. Yes. Sorry.
So speaking of solar and thermal, did you address hot water?
Yes, we did.
Okay.
Yeah.
Given that you have local water storage on each level, are you able to make use of that as the thermal mass or temperature control?
So funny enough, right after I came from Solar Decathlon, we had sat down with a local company who utilizes ceramics or like basically rocks as a thermal mass for like different efficient buildings. And they've presented the same exact idea you're talking about that we didn't think about. And I wish that's where like we needed to have this conversation with you guys before we present it. So maybe you have given us more ideas, but that's good because next year we're competing. See, this is the thing that like differs us. And we were the only no architectural school team on like the whole panel that won. Because we had this technical perspective that nobody has on renewable energy. Thank you for that, for adding that. Yes, sir.
So do you chlorinate the water anywhere in this process?
So again, the different UV water filtration system units, parts are right here, and I'll share with you. We do not do that.
Okay.
Because you shouldn't be. You shouldn't be. It's UV based. It's membrane based. Any? Which is a good comment because the existing tank that we have, we circulate the water to prevent algae from actually.
So that's the secret. So that's the whole purpose of chlorine, is to prevent algae growth. And
the one that we have right now, it's already built. There's an existing pump that would always circulate the water to make sure that there's no accumulation of any, not even dust or not even those, like sediments that would actually sit down at the bottom. Of course, you have periodic cleaning that needs to be done anyways. And there's salts that you can add to prevent algae, not chlorine. You can add salt to the system to prevent algae from growing. Definitely, and we had actually a company that came to us, and they wanted to introduce this. They called it I forget the exact name. It's like a net that lines up the inside of the tank. That net is like a hydrophobic net in a way that would prevent any accumulation of anything. To be honest, any life matter inside the tank. So they're using it more and more in commercial tanks, especially when you're having remote locations and remote like tank reservoirs that you don't really use a lot, but you still have a lot of storage of water. That was we didn't use it. Maybe that's something to actually consider in the future. Yeah. There's a lot of room for improvement, a lot. So we also use gray water. We used water sense efficient fixtures in our system to actually reserve water and actually afterwards use this gray water for different parts of the building. And you can see here the monthly demand and the volume captured. So this is only gray water. So this is only rainwater. We didn't add the gray water to this chart. So from rainwater itself, we sometimes exceed, but we always connect to the city to actually get whatever is the difference. However, adding the gray water to it and adding the next stage of water collection, we would exceed this chart easily. But that was added cost, and we always wanted to keep it within an efficient margin to be able to compete. That was a hard part because you can go above and beyond with your designs. Sometimes you go way above your budget. You don't want to do that. Well, yeah, that's what we do, right? So going back to talking specifics about different systems. These are the two stages of wind production. The first one, utilizing the UNT wind wall. This is the exploded view, the current existing design that we have. We mentioned that it's 20.1 megawatt hours per year. The next stage was actually utilizing American Wind. This is an existing company. They produce those wind walls. And as you mentioned, it's an existing technology. This is kind of different than what we're doing. In a sense, this is more of integrated into the building. This one is a standalone system. So that would be the second stage. It adds cost to the system, but it reduces more energy. Sustainability, yes, sorry. I think it's on.
Hello?
In the picture on the right,
This one?
lower, you've got the trees and that's not in perspective, it's because you've got the tree blocking.
The
any
tree
wind.
is actually closer to you.
Okay.
So
but
the
I mean,
wind turbines are actually way back.
because the one thing I've noticed is
The dimensions are here. If I'm not sure if you
I
can
can't read it from there.
I don't think if you can read it. I can't read it myself. 70, yeah.
Anyway, point is, wind works best when it's elevated and doesn't have any eddies or currents being developed by trees or buildings around it.
Yes, definitely.
So
You're right.
I question their,
Efficiency.
that they're optimum. Yeah.
So what we utilize is the data that they provided. So the great thing about actually buying something commercial is that if it doesn't do what you're saying it does, then I'm gonna blame you. It's not my problem. So they did this analysis. They told us this is how much we're gonna produce to you. This is the best unit that you can utilize for your system. So we went ahead with it. That's why probably we didn't include in our calculations. And you're right. Yeah.
Okay, so there's a terminology used for building incorporated photovoltaics, and so you're incorporating wind. And so is there a new term that we've just created here, or you
I think
created?
so.
So building incorporated wind
Yes.
generation, or, so we have to come up with a great acronym, but.
So interesting enough, the next year we have an integrated different system that's never been used, and I can guarantee it. So we're trying to integrate into this is how we compete. We're trying to do something that's so innovative that can be fitting into the design of the building, giving it an aesthetic perspective, and at the same time reduce more energy. Because most of the other teams, they had the same exact, well, this is an amazing unit, or this is an amazing building that we have. We're putting solar panels on it. That's it. This is how we reduce energy. We're putting efficient HVAC on it. This is not what we wanted. We wanted to isolate ourselves and actually think more of the innovative part of renewables.
So my second question is the wind wall that's mounted on a pole. What's the elevation there? Your wind data had to be at a certain elevation. Were you using like NREL's simulation data? Yeah.
We are. So the greatest thing about vertical axis wind turbines, they produce energy at much lower wind speeds compared to horizontal axis wind turbines, Fouts and Houts. So the calculation that you see, it was actually done by me personally, because I teach a renewable energy class. That's cool. So we had the design, and we actually I'm not sure if super familiar with wind, we use statistical measures. So we use different PDF, but probability distribution functions and CDF, cumulative distribution functions, to do the wind energy calculations, because you have fluctuating wind throughout the year. And then you need to compare it to a reference level. So normally for here, it's about 6.2 meters. So we compare the other wind elevations. We change the wind value to another elevation. So that's where we have different elevations of wind. And then we would say like, hey, if I have at 6 point or like at 10 meters, this amount of wind, this wind at 20 meters height, that's going to be a different value. So we would kind of project it to that specific height.
Future innovation is like combining the two principles for your, so you have like a strip of solar panels, and then you have your wind, then you have another strip of solar panels. And so you're generating power during the day and then at night. And then in cities, you have wind channels. I mean, you know, between the high-rise buildings and everything. And so like, this just is like a
Let me tell you,
almost a
this is something outside. This is a project that's ongoing now. So you guys drive on the highways all the time, and you see how crazy driving is, especially on like 75. I can't even drive on 75. It's like super crazy drivers. Driving, it's not. There's no. If anybody has been to Germany, they have an Autobahn, which has like the limitless. I've driven on it. It's not as crazy. I mean, I'm telling you, as 75. People actually, like, they're on their lane. They're not changing lanes, and they're respecting. So what I'm trying to say here is we have a project that's ongoing right now at UNT, designing wind harvesting systems that we put in the middle of the highway. Because cars going back and forth, this is generating amazing wind. And no, it's just wasted for no reason. And we have those long roads, highways with no lighting. You can actually utilize it for emergency purposes. Somebody needs to call something in the middle of, I don't know, in the middle of nowhere, where you have almost no solar power. You can utilize this wind energy as you go. So there's a lot of potential in wind. Wind is the next thing, to be honest, in my opinion. And hydrogen, sorry.
Okay, so I expanded that so
Yeah.
you could read it. So I'm trying to figure your numbers out. You say 4 units, maximum output 18 kilowatts. Is that for each of the 4 units or the?
Yes,
So it's total
for each one at this rated
at
wind speed,
22,
22 meg-
which we've had a lot of recently with all the high wind we've had recently. So those are only 6.5 by 6.8 by 2 feet. So those are actually a lot smaller than you might think looking at that. That the perspective is they're actually pretty small compared to the trees.
Yeah.
And it looks like there's a worm gear down there. So these must automatically turn to follow the wind.
Yes, but this is adjustable. Yeah, it goes up and down.
It goes up and down automatically also?
Yeah, so this, you might think this is not as to perspective, but it is, because it goes up and down.
Okay.
I would blame the architect. Who did the renderings? Because we gave him the units and he did the rendering.
But that's kind of an exciting output, 18 kilowatts. Do you know how much each of those cost?
We didn't go through with this. We just asked them to give us the specs. We didn't go and ask them how much, because we needed something that would be comparable. We needed something that would pay for itself within 8 years or 9 years.
Right. But that just looks interesting actually to me.
They have a maximum for the pole.
Right.
I mean, I know it's adjustable. I don't know to what height. We were told that it was adjustable. It was actually hydraulic.
Okay. Thank you.
That was interesting for me. Okay. So yeah, this is wind. We talked a little bit about the sustainability and how we wanted to, like, for instance, produce like food on campus, on the same space, to encourage students. Actually, we have a greenhouse right next to that lot that's already existing right now. So we wanted to expand on that and utilize it for production of food. And then we went to solar, where we had 2 stages. The first stage is 50% of that lot that I talked about and on site. And the next stage is the remaining 50% of the lot. We had 2 production schemes we were using. I don't know if you've heard of these guys, Silfab. Yes, Silfab. I'm not sure if it's Canadian.
So,
Production facility.
Probably.
so that's the parking lots covered with,
Yeah. So
and they can park under the solar panel?
this is the existing building that you've been to, Discovery Park. It's kind of looks, it's like a living species right here. Very interesting design. So our building is supposed to sit here. In between them, we have this parking lot. If you see it, this parking lot has 2, kind of like an equivalent space, 50-50, you'd say like it's 45-55. So we would cover 50% of this lot, and then the next stage would be the remaining 50%. When I say on-site is right here. We even considered 2 types of covering for the wind panels. We considered one design that's been given to us by a company called Solar Solution. It's a DC-based company. They do this specific design for car charges. And we wanted to do on-site car charging. By the way, car charging is going to be the next big thing too. Why? Because you can actually charge your house from your car. And that's what that company is working on, to maximizing, but they're working with Tesla to maximizing the back charging, to actually utilize different circuit breakers to get your house powered. Yes.
Needs to be company independent though, or manufacturer independent. So you work with different products that are out
True.
there.
In all honesty, the only car that can withstand that's electric right now is Tesla. And I've talked to the guy from the company. He's probably, maybe I can get him to meet you guys soon. He said the only brand of cars that we can actually work with that has the capacity of actually doing this. It's already implemented. They already have it in the car. They just needed you to modify your circuit breakers in your house to actually be able to get this energy back. And you need to isolate some loads in there. Yeah, that's true. All right. And finally, the biogas. So we have on-site food production. Oh, sorry.
On the solar parking, the modules themselves, are they, he asked the question, were they bifacial?
They were not bifacial.
Okay, so you're only collecting the energy on one side?
Yes.
Okay.
You show Silfab, are they something special or just a company that makes those?
Number one. Number 2,
Okay.
they give us the best price.
Okay,
Locally, yeah. By the way, most of this building, the main thing about it is using timber from a locally sourced suppliers.
But-
That was very important.
but did Silfab build the pedestals and everything ready to go? Or do they just build the panels? I don't know what
No, they build the
Silfab
panels.
is. The panels only.
Yes.
So you're going to have to get the pedestals and all that from somewhere
it's-
else.
In all honesty, it's not rocket science. It's very well elaborate process that you can literally outsource it in no time and they will come and do it for you.
And I know for things like this, since you've got a lot of 30-degree angled surfaces, there's a lot of different thing about the shading and how far do you space them apart from each other and all that kind of stuff. Because if you put them right up against each other, it doesn't handle it very well when the sun gets low.
NREL has its own solar simulation tool. So you can actually simulate how far you can place them away from each other. We did
Mhm.
that. We used our
Okay.
own tool that's how we got the numbers that I was showing you a little bit earlier. Yeah. 31.
Yeah, you have to get enough room for the cars to get out too, as Melon pointed out with the pedestals.
which is very interesting because the city that I'm in, that I'm from in Jordan, it's probably as hot, if not more hot than Texas in the summers. So they had this amazing, huge university in the middle of that city that they wanted to get students to come in, and they never got the chance because students would never want to step a foot in that space. It's so hot. And it's so vast that you need to walk for 20 minutes in the heat. So what they did, installed solar panels everywhere. Yes. And I showed my students that specific parking lots of that university, and we actually took the idea from that experience. So partnering, that's going to be a different story, hopefully in the future with external universities. Finally, as I said, we had talked about biogas and how we get the on-site greenhouse from the food produced to the residents, and the remaining goes into waste. The waste goes into the methane. This is also a locally designed biomass unit. We have the different, it's already online. Please take a look at the different parts of this unit. And then this methane system will give you biogas. They can actually use it for hot water. Somebody asked from me for hot water. We can use it for cooking. We can use it for just regular heating and so on and so forth.
Sun in any way? Are you using the sun in any
Here,
way for
yeah,
hot
yeah.
water?
For hot water, we can, because you're getting electricity through PV. So technically you're using solar.
You know, when I
But
lived,
concentrated heat is not.
yeah, yeah,
We're not through concentrated heat.
yeah.
We're through renewable electricity. But again, we wanted to take that away. We wanted to use biogas for it.
So when I lived in Amman, Jordan, I was always impressed by the fact that almost every roof, flat roofs, they had a black water tank, which they used the sun to heat their water. They didn't use electricity, and
I've
except
had
for moving
evacuated
water.
tubes since I
Yeah.
was a little kid. I have no idea where we got it from when I was a kid, but I think that was like one way of us reducing the amount of like energy consumption because of the financial and economical perspectives too. And finally, we came up with the app. We partnered with a company called EOS Labs. These guys actually do the complete integrated system for renewable energy, for energy efficient buildings. So we wanted to see, how would I make this building energy efficient? Imagine that you are a resident in this space. You're leaving your house, you forgot the AC on at like 70 degrees. You forgot lights on in your bedroom. You forgot whatever it is, you forgot it on. So you can actually, once this app senses that you're away and there's nobody inside, it will change this setting to what we call a way setting. On the other hand, it might actually get an idea of your routine. When do you come when you come home, when you leave, and then it will adjust the temperature of the space, welcoming you to be home. Maybe it will sense from your GPS that you're actually going home. That will change that setting for you. So we'll try to do a couple of those interesting things, partnering with the EOS Labs in that aspect. And it's a little bit about how we acknowledge the future and how we embrace. We mentioned the 2021 fiasco in Texas that we had. We mentioned how this building would have completely overcame this whole thing. It doesn't matter if you have wind, if you have, we can harvest it all. We can have energy from all kinds of directions to the benefit of us. Yeah. We've been we had worked before. Denton has an airport, and Denton had a very bad readings in terms of ozone and all different greenhouse gases for the longest time. One of our professors, Dr. John Crivello John, he is an expert in this matter in air quality. So we wanted to solve this problem. That was about 7 years ago, and we reached out to the city and what's going on? Why do we have all this ozone? It's not even a dense city. It's how our numbers are worse than Dallas. So they eventually figured out that was the sensors were so close to the airport runway that we're catching all those fumes from the from the airplanes. Now we needed to change the location. From Dallas.
Let me ask this question from the web, and I'm going to try to paraphrase it. The when you sell the energy back to the grid, given that it's renewable, or given that what the Dallas or conserve providers are already 100% renewable. Is that true?
So
Can you claim, the question is, can you claim CO2 reduction given that you're selling the power back in that environment?
I think one of you guys need to mute the. Yeah. Okay. Okay. So the city of Denton gives you back, if you sell power to the grid, it gives you 38 cents. Oh, sorry. 3.8 cents. I wish for each kilowatt hour that you sell back to the grid. And we've been communicating with the city. So that's lower than the actual price of power, you know. And all the calculations of the money generated, all the economical perspective was based on that specific charge that we actually would be able to harvest. We didn't even include the tax credits, because there's a lot of tax credits involved in this, and you probably guys are more aware of this. Yes.
I just wanted to state that Denton is a municipality-owned utility. So they're responsible for the electric generation, where like here in Dallas, in the Metroplex, we're deregulated. So we can go out and buy our power from anyone, right? So
That's easier for you.
So,
Oh, yeah.
so is there interest in making UNT as a whole, because you've got different physical locations, closer to net zero? For instance, if you generate extra power here, maybe you can convince Denton to let it offset power usage on the main campus. Or maybe you could look also at putting PV and other things on the main campus to try to offset that.
100%. That was the dilemma that we went in when we decided to calculate our savings. Do we calculate our savings based on selling the power back to the city, or do we calculate it? We have a campus right next to us. We can sell it back to the campus and save their energy. So we eventually decided to sell it to the grid to give better perspective to the audience, because that's what everybody's doing. But in reality, we wouldn't be selling it to Denton, to the city of Denton. We are actually going to pump it into the main campus, the main building, and saving the energy, the bill. And that's how we're going to do it.
Can I ask some non-engineering
No,
questions?
please, by all means, yeah.
Since I'm not an engineer, but does this building already exist, and are people living in it?
No.
Oh,
This is
okay.
just a design.
Just a
Yeah,
design.
that's. I
20
wish so.
Okay, and is it only for the engineering students that will be working in the design hub or whatever? Right.
It's only for the graduate engineering students at there's a lot of graduate engineering students
Okay.
at UNT. And what we wanted to have is a vibrant, fun to live in, energy efficient, net zero energy building for students. Because remember, we can utilize at the end of the day this building for our own research, human
Right.
comfort. This is a huge research, air quality,
Right.
HVAC. We are tier 1 research university that we can actually utilize this building for.
And then what is the recommended price that you're going to rent out, like a 1-bedroom versus a 2-bedroom?
A 1-bedroom was $920, all inclusive.
Yeah.
Which
That's
means all inclusive,
All utilities.
all utilities, even food inclusive, because
Oh.
whatever food produced that is going to be free for residents. The 2-bedroom was for 1270,
Awesome.
if I'm not mistaken.
Bedroom, would that be for married housing?
Married or
Married or,
or like
or have a
partners or-
roommate, but the thing is, yeah.
yes.
You have plans to try and incorporate some of these efficiency improvements into the existing buildings on the UNT campus?
I would love to. So, to be honest, again, when I started this, we didn't know where we're gonna go with the competition. Even until we got to Colorado and we saw the size of this, we were not aware. We didn't even think that we're gonna make it to the finals, to be honest. We didn't know that we're that good, to be honest. And we should have believed in ourselves a little bit more, because I can tell you that they were not putting their full time into this project. And I can only imagine if they had been doing this full time, because they did this for credit. Now we know what we're in for. Now we know how big is this competition, how we can actually use it to improve the quality of research, undergraduate and graduate research on campus. Actually, the DOE started this zero energy designation for institutions that we want to be part of. We started this energy certificate. So UNT will be listed as a net zero energy designated college or school for all students around the world and nationwide to come to us to get their net zero energy or sustainable, efficient building education.
Just my opinion, but I think
Yes.
that's a lot of engineers in one spot. Why wouldn't you have a certain percentage of the population with another discipline, just so it's not inbred or whatever?
Let me see this area right here. I guess this area right here has there's a community of houses, and we have a garden right next to us that we wanted to open to the community kids to come and play with, play in that area. I can tell you this, it's dangerous to have so many engineers in the same spot. We have no sense of money. We'll try. We'll try. I can say from my dad, he has a very good sense of humor. But eventually, we wanted them to get out of their shell. And this place gives them more of those those common spaces. Because when I used to live in student housing, we had nothing other than going to get food and come back to our rooms. It was very boring. And guess what? Student housing needs to be vibrant, needs to be very interesting. We need music people in our life. And I wish I had some in my college years. I didn't, unfortunately. Yes.
Well, also, if you can get, by the way, this is only proposed. Okay. And like he says, they're going to do better next year, right? And so maybe they'll have a better proposal they can get through the Board of Regents, whoever it is. So if you can build this, it gives you a way to try to attract graduate students just because of where they'll be living.
Yes.
So if you think about it from the point of view of the university, yes, getting you guys on the map as a green, energy efficient university, and with student housing, they can come to live there, and they're doing research about the housing. This is all a win-win. So I would think the university would be very happy to fund all that. And by the way, I know you have a couple last slides. You haven't told us how you did comparison to the other university, to other entrants in the competition, and who won your category over you. So describe that too.
I'll say that. Going back to the first part of the question, once we designed the building, I took the building and I was going around with my students and I thought, would you live in this building if I invited you? It was like, of course, tomorrow. When is it? Where is it? So eventually I came down to you have to apply and you have to get in. and approved, and like that's going to be an interesting term. Randomly, when we chose to be, we wanted first to be in the single family building division. Then we decided to do multifamily, which is exactly what we want. I randomly selected the University of Arizona presentation that 1 second. We didn't even, I didn't even select the first or the grand winners. I went to this division and I selected the second one because I personally like Arizona. Guess what? They won the grand jury of this year. So apparently I was using the best presentation at the time. And somehow it's Chinese year. That's a good finale. And I became friends with them afterwards for that specific purpose. So yeah, that's how we won the competition. So the people who won our division actually ended up winning the grand prize, the grand jury position. So we were up against the best. And I'm sorry, the finale is right here. This is just an introduction what the building is actually constructed of. And that's it. Those are partners. I would love to thank all of you guys for your great questions. And I would love to thank my team, my partners, and I hope that I can come and present to you my idea for the next year, get your input before I go present. You can give me better ideas and better suggestions. And I think that what you're doing is amazing. It's so rewarding. That's the grand finale. Thank you so much. Thank you. You wouldn't expect that.
Inside right now. So there's a lot of noise from out there. It's another event that they're holding today in the library. Yeah,
So, great closing, by the way. So one thing we didn't hear about was storage. Are you planning on any type of storage? So like at night when, intermittent wind, but there is no sun, where are you going to be? You're still going to be grid connected. So were you thinking of storage in any way?
Yeah, so the energy efficient buildings and net zero energy is you should have storage because it's going to add cost to the system. So you exchange energy with the grid. So you're at the end of the day actually making this a net zero energy rather than adding more money to store the energy on site.
Yeah, so that concept is you consider the grid your storage.
Your storage, exactly. Thank you.
So say you're the project manager on this and you're building this in a couple of years and then you're contractually obligated to run it successfully for the next 3 or 4 years. Which of your energy systems are you most concerned use what they should? I mean, is there anything that's less mature?
The
than
only
others?
one that is very less mature, I think it's the methane. And the reason behind that is basically for the dome. We have a dome-based storage for the methane, and we don't have enough experience on how to make this. We're probably gonna have to outsource it, but that's the only thing that I don't have enough expertise about to build. Yeah.
But methane accounts for only 3% of the energy production and use anyway, just like the building integrated wind turbines
Yeah.
are only 3% or so, 1/36. So I had 2 comments and a question. I'll try to make it fast.
Please, yeah.
Yeah. Comment number 1 was that there is a trend to, no, comment number 1 is that students who live together and interact with each other will learn at least as much from each other as they do from the professors. I know that was the case in grad school for me. So co-housing of engineering students together is great. Mixing in a few music students would be great too. But that's an important thing for students to learn from each other. And number two is there's a trend towards people like us, the older retirees and things, wanting to participate in this. This is a very exciting presentation about a place that us older people who are not traditional students would like to live in also. And for cultural enrichment, there's a trend for having retirees participate in university activities. So you could consider nearby housing with similar principles to accommodate people who want to do lifelong learning.
Certainly.
And then my question is a simple one, which is with rotating parts right next to the walkways, how is the architecture designed so that arms and legs and heads don't get cut off by your building integrated wind turbines?
First of all, it's not harmful. It's very light plastic, number one. Number two, I don't know if you've seen it, but there's a net. You can't get to it. You can't reach out.
There's a grid.
There's a grid. Yeah, there's
Yeah.
a net. There's a grid.
That's what I figured, but I couldn't see
Yeah,
it in
yeah.
the picture.
There's there's a net that you can get to the turbines. Yeah. But I would like that's a good comment. Then would you leave your house and stay there for like a month just to experience the space? For like,
That's a great question.
yeah.
Yeah. So say this happens, it gets built, and your students or your grad students are living there. Who's going to actually be responsible for the operations and maintenance? Yeah.
She already
No,
made
no,
me
but what-
actually, but
But what I'm asking is that would the students, the engineering students, be involved in managing their environment as part of that, so they would have a full understanding of their living environment?
so normally with the solar decathlon, what happens if there's a good idea from a design perspective, you go and seek funding. They will give you a seed fund of $50,000, which is not going to get you anywhere. But if you have enough funding, then you go and like build your design or build a smaller version of it. And that's the build challenge compared to the design challenge that we competed in. So an idea was actually compete in the build challenge to raise some money for someone's house, to incorporate all of those technologies into someone's house or someone's residence or someone's building, to actually be able to experience and get data out of it. If this building is to be built, it's going to be a joint venture between UNT and external sponsor. And that has to be managed by UNT because it's students living there eventually. We're obligated by state rules and by education rules, Department of Education, that we have to actually give them a specific level of comfort, I would say. Would the students not want to be participating in this? Yes, this is their baby. This is what they've been working on days and nights. I can tell you horror stories where I had literally to stay up many nights to 2, 3, 4 a.m. with students working on Zoom and on Teams, trying to put stuff together, trying to put all those visuals together to be able to communicate. So we're good, as I said, engineers, we're good at doing numbers. We're bad at communicating them. Very bad, right? Thank you.
My question is about maintenance. I know, the North Texas has an engineering, building engineering division, where they pay employees to maintain the facilities. This will be a unique facility. Would you need a specially trained group of people just for that facility? Or,
One thing that we thought about is all of these systems are very new, so fairly interesting in terms of like having different research groups. So we have a research group that's doing methane production on site, on campus. We have a research group that's doing the wind. So we can make those students work on their own research where they live. And that's how you get the maintenance. Now not only the maintenance, that's how you get the improvement of the system as you go. You're living there. You're trying to make your house or your environment better by doing more research on what you are actually experiencing right there and then. That was yeah. So we have to have help for sure. All kitchen duty is a different story. Yeah.
Well, we will want to take you up on your offer to come back here and make another presentation to us, and
course.
we'll ask all these questions again or different questions. So hopefully that will help you tweak your presentation a little bit too.
Definitely. I would love to. And I thank
Okay.
you guys so much for having me and for giving me this amazing opportunity to exchange ideas. You've given me a lot of ideas that I share with you. And I guess that would make it an obligation from me that I have to come and present to you my idea for the next for the next little decathlon.
Yeah.
And we have you as a whole entity as one of our advisors in the team.
Program as a sponsor of some kind. And so we'd like to continue the discussion as an opportunity for the future.
And I would love that. And I would love if you guys have any ideas, which is something that I also wanted to mention. If anyone has any interesting idea in energy, something that's so innovative, UNT only asks for material from anybody who wants to sponsor a senior design project. We don't ask you for any shop fees, any labor fees, any kind of fees. We only ask you to provide the material to make this design. All the software, the hardware, also all the IP, the intellectual property goes to you if you provide the material. We don't own anything. We only care about the students' learning. So all of those ideas that you've seen, it's sponsored by external sponsors. They haven't paid a lot of money, but they've made the students intrigued enough to actually do those designs in the first place. So if you have any ideas, if you wanted to sponsor a senior design project with no more than just the material to build this prototype, we'll be happy to help. We have a lot of students eager to learn.
So there's a question from the chat.
Yeah.
From James Ornstein. Are you going to participate in Congressman Burgess's annual Energy Fair and Summit, probably in July in Denton?
I don't think so.
You don't think so? Okay.
Yeah.
Okay.
They're trying to intrigue. It's not Chinese New Year, no.
Is this good? Okay. So for anyone joining us remotely, there's a Chinese New Year celebration going on in the lobby of the library, and that's what all this background noise is all of a sudden. But it's very entertaining, that's for sure. So I do have a question. Have y'all thought about incorporating heat pumps into the building? Because now they've come out with 110 volt heat pumps. They should be very, very efficient, very low energy use. That might help save a lot of energy in that building.
That's very true, and we didn't incorporate it. We should have. As I mentioned before, I think we wanted to use symbol terms to get into the finals, I guess, and we wanted to simplify. We couldn't simplify. It's actually more complicated than what it was originally, but we wanted to simplify so the students would be able to work on it. Remember, eventually this is student work.
Yeah.
But I guess in the next years, for us, for faculty, we have more experience of what to expect and what to actually portray. So we definitely would like to actually incorporate that. Yeah, that's a good point.
All right, awesome.
That's a geothermal heat plant, geothermal, but the geothermal heat pump is the wells are existing. What we're talking about, there's a solar heat pump that we can actually incorporate. We have passive. It's ammonia-based HVAC systems, for instance. that we wanted to also incorporate. We're incorporating something we call phase change material in the building, where in the walls, instead of insulation, you put phase change material that would change phase depending on how much heat is it's absorbing, and then it will project it into the space.
Really?
So that would save a lot of energy in terms of heating. In the future. So that is also, that's a very elaborate research at UNT. It's a solid that changes phase into a jelly kind of material after it absorbs heat. Yes, because it only one directional. It absorbs heat from one side and it rejects heat to the other side. But it collects the heat in the, like for instance, in the daytime. Yes. I mean, commercially available product as into what, to some extent, but it's not completely used in buildings yet. It's an ongoing research. And Dr. Wei Wan Zhao, she used to work on Argonne National Labs, if I'm not mistaken. That was her like postdoctoral and like her whole research now at UNT is based on PCMs, phase change material.
Because right now our insulation for exterior walls is to prevent something from
Right.
Yeah.
And so what you're talking about, you're using physics
Yes.
to actually keep the inside insulated
From the outside.
That's pretty interesting.
Yeah. Thank you.
Yeah. Thank you.
Thank you so much.
Appreciate it. Mhm.
Thank you guys.
So before we conclude the meeting, I do want to put out a request to the membership at large. And I've been talking with Tracy Wallace about this a lot, but we want to get to a point where we can routinely distribute free LED light bulbs at events we're going to be at, like the event in 2 weeks here or 3 weeks. And then the events that Tracy is looking for volunteers for. But we've given out, I think, something over 500 LED bulbs this year. But I would really like to ramp that up and give away a lot of LED bulbs and have them available for people that show up at these events. And so we have a letter developed that you can hand to Lowe's or Home Depot or whomever else that has light bulbs that they can donate. And it basically gives a little background about NTREG and Green Careers Dallas, and you know, how we're both 501c3 organizations, we're nonprofits, we're just doing this to try and help out the community. And they need those letters to make the donations. And so all you need to do for the letter is just fill in the store number and the address and hand it to them. So if any of you know the store manager at a Lowe's or Home Depot, or you go there all the time, they know you, please come see me and I'll get one of those blank letters to you so you can go talk to them about getting some LED light bulbs so that we can distribute those on an ongoing basis. Or if anyone wants to just contribute LED light bulbs that we can distribute for free, that's certainly welcome as well. Yes, sir. Yeah, I like that. It's a good idea. Yes, sir. Yeah. True. Yeah. So, anyway, that's the initiative we want to pursue going forward. So, again, if anyone has any questions, comments, want to talk to me about it, just drop me an email or text me or call me, whatever. So with that, we will, one other thing. Sally, who runs this library, has been talking to the co-op out where she lives, and they're willing to subsidize solar panels for people in their area. But she has some questions. Matter of fact, here she is. Hey, come here. Yeah. Yeah. I was just mentioning to everyone your communications with the co-op you're in. And so I'll let you give them a little background and then.
Sure.
Yeah.
Okay,
'Cause
great.
we have a lot of people joining remotely.
Oh, great. Thanks, guys. Yeah, my husband and I live in Collin County, and we're part of Farmers Co-op Electric. So they're wanting us to switch over to or add solar panels to our roof, which is a great idea, and we're all for sustainability. But my questions are what do I need to be looking for? And my thing is, I don't like conduit running over my roof, and I see that's for a lot of the houses. For me, it just doesn't look appropriate. I would rather it come through my roof line under my roof. So those are the questions. And what should I be asking? I know we talked about coverage, insurance coverage, and things like that. But what else do I need to know? Because I really don't know. And how much? What's the cost? What should I be looking for? The average cost? And then the co-op will. I have like this huge stack of paper that I'm trying to read through to tell me what the co-op will support and how the buyback goes, because I'm not clear on that either. So there's just a lot of questions. Okay. Oh, good, good. Mhm. Oh, good. And then the other question I have that's not related to that, but is with the current heat wave that we're going through right now, how is that going to affect the grid and how will it affect this area? Because this is the library, we're not part of because we're on the hospital grid. But I have a ton of people that live in apartments. How am I what can I do to help support them? Because during the winter outage, they lost power and didn't have access to water. So we were the warming center. So this time we'll be the cooling center, but we still had to provide whatever the needs are that they have for this community. Yeah.
So actually, read my shirt. It's focused off of last year's event, but that's a great question because we were requested or asked by the city of Dallas in regards to their CCAP program on their resiliency focus. And so we supported them in putting together a questionnaire on what's required for a resiliency center. And you're absolutely right. Our focus last year was on the cooling, the cold weather, but actually Texas is more familiar with rolling brownouts during the summer because the air conditioning loads. And this usually happens later in the summer, not so early. This is May, it's still May. And now they're talking about rolling brownouts. And it's all about the maintenance of guess what? The gas-fired and coal-fired power plants, right? So we're still generating a lot of power, maximizing our power from both wind and solar statewide going into the grid. So that's the only thing that's really saving us because these plants are offline. So those are resources available for you. We'd like to share those if we can.
Please.
So the city's already taking a look at this. So I'm really proud of the fact that you use this as what we call a resilience center. So because hopefully these rolling brownouts aren't going to be as severe as that as a snowmageddon, but they could be, and so we need to plan accordingly. And
That's our concern. Also, the city of Dallas, but some of the public libraries will be having generators installed behind our buildings so that we are available during those types of events, whether it's tornadic weather or extreme weather. Then we're here to provide shelter and provide aid. So that's one thing that I'm excited about, especially I think we're one of the ones that we have in the generator. So we can have that type of maintaining the community because we have a lot of families and people who don't speak English. So we have, I think we just received 166 Afghan refugees and Ukrainians. So we're going to be busy.
oh, wow. Wow. Well, congratulations on that. Yeah, we respect you for that program. So.
If you go to our website, www.ntreg.org,
go to the bottom, there's a discussion group. You have to actually sign up, and then once you're on that discussion group, especially your questions about your house. I mean, any question, yeah, and there's no such thing as a stupid question. Okay.
Because my husband also wants to put a generator in the back of our house.
I mean, I've studied that too.
We can post all kinds of questions.
Yeah, that's the kind of question you can ask on here. All right.
Describe the next programs. Okay, thank you.
You're welcome.
Okay. We want to thank Hassan for his program today. Our program next month on June the 11th is going to be about Alexander Farmakas. He's the sustainability manager at the City of Farmers Branch. He is going to talk about their Farmers Branch sustainability efforts in the solar farm they're working on to power all of the government offices in Farmers Branch completely off their local solar power generator right there. On July 9th, Roy Shar from Excel Geothermal will talk about ground source heat pump technology. This comes up all the time where people in our group want to know, what is this ground source heat pump? How does it work? Et cetera, et cetera. So he's going to bring some examples of some of the equipment. Actually, he's done this before, so he's got example equipment, small things he can bring to show you what it looks like, and a slide set to talk about how ground source heat pumps will work. And then in August, Garrett Rosser, the energy manager of Dallas College, the community college here in Dallas County, will talk about, in general, energy sustainability update for Dallas College. By that time, they'll have done their budget for the next year, so they'll know more information about what they'll actually be doing. So that's why we wanted to wait until August. Paul and I are still looking at coming up with some presentations for September through December, but some of the ones we're looking at are Joseph Bater, who is he is a consultant involving energy storage and use from geothermal wells. So he works for a company which is looking at getting heat from deep oil wells, essentially, that are no longer being used, and also storing energy in them by pumping heat into the wells and getting it back later. And so they've done quite a bit of research. They're doing more. So I'm trying to get him to come and talk to us. Also, Larry Bentley, these are from EarthX at the Dallas Convention Center a few weeks ago. Larry has done he's part of Engineers Without Borders, and he's done a bunch of solar projects in other countries. And so they just sound like really interesting things we'd like to learn about these solar projects where they go to some small community in another country. Off-grid projects, exactly. These are little off-grid projects to get that little community working. And so we have other things we're working on. Thank you.
Thank you. So with that, we will close the meeting for this month and hope to see everyone back again next month. Thank you all.